Who should decide whether or not we should even consider this technology? Should it be one country unilaterally deciding, or should a group in the UN General Assembly sit down and decide, or in the board meeting of ExxonMobil?
Welcome to Today I Learned Climate, the show where you learn about climate change from real scientists. I'm your host, Laur Hesse Fisher from the MIT Environmental Solutions Initiative. When people talk about climate change solutions, they're usually talking about either stopping adding CO2 to the atmosphere or how humans can adapt to climate change. There's also a third option that's starting to get more attention.
My name is Janos Pasztor. I am Executive Director of the Carnegie Climate Geoengineering Governance Initiative.
Mr. Pastor is an MIT alum who was appointed by Ban Ki-moon, the United Nations Secretary General, to lead his office on climate change. He also worked on the UN Paris Agreement, where nearly every country around the world pledged to cap global warming.
Climate change action has been focused on first reducing emissions, which was correct. Then at some point, people started thinking that we also have to adapt to the changes that are already taking place. But now when we put everything together, we have to realize that there is something else that is needed. Even if one were to stop all global emissions today, which of course is a very difficult thing to do. But even if we were to do that, there's enough carbon in the atmosphere that the global temperatures would still rise and would stay like that for a few hundred years. So we have a problem.
In addition to no longer adding CO2, we also need to take CO2 out of the atmosphere. And if we can't take out the CO2 fast enough, then we could try to reflect sunlight or otherwise stop the Earth from warming. This is why some people are starting to talk about geoengineering.
The way it's defined, it is intentional, large-scale interaction with the atmosphere. Large scale, meaning planetary scale, in order to address the climate change problem.
Generally speaking, there are two types of geoengineering. The first is about sucking existing carbon dioxide out of the atmosphere. There are a lot of ways that one could do that. We all know that plants absorb CO2, but so do soil and rocks. And there are things that we could do to help accelerate what nature already does. People are also creating chemicals that react with the CO2 in the air to capture it and turn it into something that could be stored or used for another purpose, like plastics. We could also combine these two approaches, grow plants, burn them for electricity, but then immediately capture the CO2 and store it, which could produce energy and suck CO2 out of the atmosphere. If you want to learn more about these technologies, we'll have some quick reads in our show notes. While there are definitely things that need to be worked out, like land use issues and how to pay for these technologies, removing carbon dioxide out of the atmosphere is something that people are paying more attention to.
There are lots of experiments going on, lots of little companies doing things. We saw that at the UN Climate Change Conference in December of 2018. There was a lot more discussion about carbon dioxide removal than ever before.
But where there's less known and more debate is with the second type of geoengineering, called solar radiation modification. This kind of geoengineering doesn't try to reduce the CO2 in the atmosphere. It focuses on reducing the amount of heat that gets trapped there.
There are ways to change the clouds and make them thinner or make them more reflective to alter the radiation balance of the Earth. But there are other methods, like changing the albedo of ice, for example, in the Arctic. There's an experiment going on right now in Alaska to do that. Both of these would result in cooling the planet. Now, this looks like science fiction stuff, but one thing that people have thought about is space-based mirrors. You know, shoot up a bunch of rockets and put up big mirrors that would literally reflect sunlight back into space before entering the atmosphere. So there are different things scientists think we can do, but the one that is most commonly talked about is the stratospheric aerosol injection.
That's a fancy phrase for spraying a particular kind of particle, a sulfur aerosol, into the atmosphere. This part relates back to the conversation we had with Professor Dan Sitso in our episode on clouds. I recommend you checking it out for more info on how particles help form clouds. Okay, so this technology, stratospheric aerosol injection, mimics something that volcanoes do naturally.
The volcano erupts and lots of rocks and dust and everything else escape, including so-called sulfur aerosols that reflect sunlight back into space and cool the temperature of the Earth. And in fact, after a major volcanic eruption like the recent one in Mount Pinatubo in the Philippines, the world could measure that actually the global temperature went down by about 0.5 degree and stayed like that for a year almost, and then went up again.
And so some scientists are exploring how to replicate this artificially. For example, jets could circle the Earth a few times a day, spraying these particles into the upper atmosphere. And then these particles would reflect about 1% of the incoming light from the sun, thereby cooling our planet. But, of course, there's no free lunch.
This technology also has impact. First of all, it reduces sunlight that comes to reach the Earth, and that will have an impact on agriculture, on forests, on ecosystems. It will also change the weather patterns, and we don't quite know how much, but we need to find out before we take any decisions.
The other issue is that if this technology were to be used alone without reducing CO2 in the atmosphere, it's kind of a Band-Aid solution.
Once we get going with solar radiation modification, you can't just simply switch it off. If you do it for, let's say, 10 years or 20 years, and you suddenly stop, and you haven't reduced the concentration of greenhouse gases, the temperature will jump up to what it would have been otherwise, and jumping up quickly would be even worse for the ecosystems than slowly ramping it up. So you're taking lots of decisions for future generations, and once you start it, they don't really have a choice. And then there, of course, and that's the biggest challenge of all, is that we only have one atmosphere, and this technology would manipulate that one atmosphere. If we get it wrong, we've had it. So we need to be absolutely sure that we're doing things right. There are no easy answers here.
In his organization, Mr. Pasztor is trying to open up a global conversation about how we as a society make decisions about geoengineering while these technologies are still young.
On solar radiation modification, nothing is happening other than a few modeling ideas and a few maybe small experiments. But first of all, who should decide whether or not we should even consider this technology? Should it be one country unilaterally deciding, or should a group in the UN General Assembly sit down and decide, or the UN Security Council, or in the board meeting of ExxonMobil? There is, for example, an interesting scientific paper that showed that it would be possible to do hemispheric, only northern hemisphere deployment of solar radiation modification that could help in reducing frequency and intensity of hurricanes in the Caribbean. There's only one problem. It would result in a massive drought in the Sahel in Africa. You cannot have just the northern hemispheric countries decide we're going to do this, and who cares about the Sahel? The systems are interconnected.
Interestingly enough, one of the complicating factors of stratospheric aerosol injection is that it could be the cheapest technology to deal with global warming.
As little as $2 to $3 billion annually for the first 15 years. Now that's nothing compared to the global cost of emission reductions or carbon dioxide removal, which would be measured in the trillions. So these are questions that need to be addressed now. Before somebody, it could be that a country decides to announce deployment in a few years from now. Or an individual who is a wealthy person says, I want to save the world. And I'm going to use my money and I'm just going to start flying these airplanes and start spraying the stratosphere with aerosols. Geoengineering, it's not just philosophical, it's not just ethical, but it's actually basically a risk management issue. Each technology has some positive and some negative impacts. There is no silver bullet and there are no easy and quick solutions.
So there's a lot more that we need to know in order to understand how these technologies will work, and more importantly, how parts of the world could be impacted. But once we know, it's then not a matter of research, it's a societal decision we'll need to make about intentionally modifying our atmosphere, our planet. This episode was one of the hardest to create so far. It is a real challenge to boil down something so technologically and morally complex as geoengineering into 10 minutes. So in our show notes, we've included more resources where you can learn about these technologies and some of the issues that come along with them. Now, you may or may not be part of the UN General Assembly, but you do have political officials who represent you, and perhaps may also be connected to nonprofit organizations working on these kinds of issues. Share this episode or the resources in our notes with them and open up the conversation so we can make informed decisions about our future. Thank you for joining us on this first set of episodes from Today I Learned Climate. In the last month and a half, we've talked about how planes and condensation trails warm our planet, how clouds can cool our planet and what particulate matter has to do with that. We've talked about steel and cement, hurricanes, how to think about risk and uncertainty, how climate change will impact different parts of the world in different ways. And we started digging into some of the different solution areas like carbon pricing and geoengineering. But we are just getting started. This was our first set of episodes, and we really hope that you enjoyed them. We're going to take the next few months to work on another set of episodes for you that will release this September and October. And in the meantime, we love hearing from our listeners. So send us your questions, your comments, what you would like us to cover in the next set of episodes. Tweet us at TILclimate or email us at tilclimate@mit.edu. Thank you so much for tuning in, and thank you to Mr. Pastor for speaking with us for this episode. See you next time.